Hi students, welcome back to Chakravarthy E Classroom. Today we are going to discuss a fantastic question from time and distance chapter, that too from the concept by name relative speed. Alright, this question has been sent by one of our students only. Already I've kept that one in the doubt clarification session of our course. And for the students who follow us on YouTube, for them exclusively, I'm recording one more time. See students, this is a fantastic question actually. Nowadays, in many competitive exams, the examiner is asking questions like this. First, I'll read the question for you. After that, we won't do this question immediately. I just explain you the concept of relative speed in a nutshell, because there may be some beginners also. After understanding what is relative speed, then we will go and solve this question. Okay, by the time the students who already know the concept of relative speed, you just take a screenshot of this question. Very good question, I'm telling you. Fantastic question. All right, and you try to do it by yourself. What they have given here: a thief snatches a purse from a girl and runs away at a speed of dash kilometers per hour. They have not given the speed, you see, because this type of questions they are asking in many competitive exams nowadays. Okay, that we need to find out. Then girl starts chasing with less speed than that of the thief. Now you see, less speed than that of the thief. Then after some time, the thief changes his direction towards the girl, due to which the girl catches the thief in 2.4 hours. What a fantastic information they have given, right? Further, they have given, you see, if the thief travels away from the girl for 2 hours, then the speed of the girl is dash kilometers per hour. What a fantastic question is this one. All right, nowadays, as I told you repeatedly, I'm telling you students, in many competitive exams, they are giving this type of question. Now what we need to find out here: what is the speed of the thief, we need to find out, and what is the speed of the girl. All right, but the options also they have given in a different way, you see. Which of the following option or options satisfies or satisfy the blank given in the same order? In the same order we have to find out. What is this one? The first one they have given, you see, like this: x comma 2 by 3x. This is actually 2 by 3x. You read this one like this: 2 by 3x actually. Okay, what's the meaning of this one? X comma 2 by 3x. The first one is the speed of the thief. If this is the speed of the thief, according to option number 1, if x is the speed of the thief, 2 by 3x must be the speed of the girl. This is first one they have given. And second, they have given 24:16. What do you mean by this one? If the speed of the thief is 24 kilometers per hour, girl's speed must be correspondingly 16 kilometers per hour. And the third one they have given 2.5 g and g. Don't get confused, sir, where is this x or where is this g? One variable they have used that one to show the ratio of the speeds of thief to that of the girl in the same order. Now 2.5 g. What do you mean by 2.5 g here? 2.5 g means this is the speed of the thief and this is the speed of the girl. This is what exactly they have given. And finally students, what they are asking here, you need to go for option A if you feel only 1 and 2 are satisfying those values. Go for option number 2 if you feel only 2 and 3 satisfy this one. Then option number C, only 3 means this one. Then D, all the 3, but the next one is none of this. This is what they have given. But how fantastically they have prepared the question. You have to do this type of questions. Okay, first, the students who already know the concept of relative speed, you just try to do it by yourself. After that, I'll explain you clearly. And for the beginners, what I'm doing now, I'll take 5 minutes to explain what is the speed of the speed based on the relative thing or relative speed concept in a nutshell. What is relative speed? See students, it's one of the very important concepts of time and distance chapter. Relative speed can be calculated in 2 ways. One is in the opposite direction, second one is in the same direction. I'm just explaining you in a nutshell. The beginners, any beginner is there who is watching this one, try to understand it in a proper way. All right, opposite direction. First type is opposite direction, second is same direction. Okay, first let us discuss this simple concept, opposite direction, then I'll go for the same direction. See students, relative speed. Suppose two objects are there, two vehicles are there, both are in the moving condition, both are in movement. Suppose this is, let us take place A, this is place A, okay, and this is place B. All right. Now from this place A, let us take bus starts from here, and this is car. Listen carefully, the beginners. Speed of the bus is, let us take x kilometers per hour, and speed of the car is, let us take y kilometers per hour. Both started simultaneously. That means at the same time from two places and started towards each other, traveling towards each other. In this case, what happens? Obviously, the speed will become relative speed in the opposite direction. So in physics also you have learned this one at your high school level, even in mathematics also. All right. So here both are in the opposite direction. Here speed becomes, I'm writing relative speed here is obviously x plus y, as simple as this one, x plus y kilometers per hour. I hope this is clear for all of you. All right, let's take some numbers otherwise, so that it would be clear for everybody again. Now you see, let's take the speed of the bus is 40 kilometers per hour. Okay, then speed of the car, let's take 60 kilometers per hour. All right, and the distance between these 2 points, let us imagine as 200 kilometers. Let's do a little further, 200 kilometers. If both start towards each other, after how much time, in how many hours both are going to meet each other on the way, is the question. If this is the case, students, here they are asking for the time. You know the formula of time, generally time is equal to distance by speed, isn't it? But here students, now this is not the direct distance. I'll tell you, a particular word is there for that one. And here speed also not normal speed. Here speed is obviously relative speed, just now we discussed, because both the objects are moving towards each other, and both are in the movement, of course, right? Now the distance, here particular term is there. When you are using this relative speed concept, here particular term for distance is lead distance. Let us call it as lead distance. Okay, then how to solve this one, students? Here obviously I need to find out the time. Time is equal to lead distance by relative speed. What do you mean by the lead distance here? Lead distance means when both are starting towards each other simultaneously, the target for both of them to cover is 200 kilometers. This is the lead distance. How much time would it be taking for this one? Simply time is equal to the lead distance is 200 kilometers divided by speed. Which speed I have to take? Shall I take this 40 kilometers per hour alone or 60 kilometers per hour alone? The question is very simple. You can answer that very easily. How can I take only one speed into consideration when both are coming towards each other? Simple common sense, right? We must say the speed is relative speed in the opposite direction. So relative speed in the opposite direction means you need to add both of them. 60 plus 40, it will become 100 kilometers per hour. Now in how much time both are meeting each other on the way? Very simply, that should be 2 hours is the right answer. 2 hours. I hope the concept of relative speed in the opposite direction is clear for all of you. Since the beginners are there, I have explained you this one. Actually, it's a very lengthy concept. In our regular course, we have discussed that one for 45 minutes by taking different types of examples. Okay, now this is clear here. Now this is opposite. Then what do I mean by the same direction? Now you focus. Many students are getting confused here how to find out or how to apply the concept of relative speed in the same direction. Let's take the same thing here, whatever we have taken. There is a place by name A, for example. Bus is here and car is here. Same figures you take directly. Speed of the bus is 60 kilometers per hour. Speed of the car, how much we have taken? 60 for car we have taken, 40 for bus. It will take the same. There is 40 kilometers per hour and car is 60 kilometers per hour. Let us imagine in this way. Simple concept. Let us imagine in this way. Now the time is 7 o'clock, for example, 7 a.m. Both started simultaneously. 7 a.m. they have started. Now the simple question is, what is the distance between these two vehicles after 1 hour? That is at 8 o'clock. Simply we can say in 1 hour car is going to cover how many kilometers here? 60 kilometers. And bus is going to cover only 40 kilometers, because per hour it goes 40 kilometers, per hour it goes 60 kilometers. Now here bus is here, car is here. What is the distance between these two? 60 minus 40, of course 20 kilometers distance is there. Hope this is clear, right? In the next step, suppose if they ask in this way, if bus increases the speed to 80 kilometers from this point, when the bus is going to catch the car? In this case, students, the speed becomes relative, and this 20 kilometers is going to be considered as the lead distance. Now we got the idea, right? Let us expand this one. Let's start from here only again. Now you understood this one. If bus increases its speed to 80 kilometers per hour, so now actually it is 40 only. Let us take it as 80 kilometers per hour. Then car speed is same 40 kilometers per hour. When the bus is going to catch the car, or how much time would it take is the question. Okay, so before answering this question, students, let us go with a simple question. Then we will come back to this one so that you can understand the relative speed concept in the same direction in a proper way. Take the similar example here. Suppose this is place A. Okay, now here one bus is there, one car is there. Take the same figures. Bus speed is 40 kilometers per hour, car speed is 60 kilometers per hour, and now it is 7 a.m. Okay, now here at 7 a.m. both are not starting simultaneously. I'm just going a little in depth. Here let us imagine that only bus is starting at 7 a.m. Now 8 a.m. after 1 hour car follows the bus. Now we understand the question. Bus starts at 7 a.m. with 40 kilometers per hour. After 1 hour car follows the bus with 60 kilometers per hour. When the car is going to catch the bus on the way? Here purely relative concept is going to be applied. Now you are going to understand it very, very clearly. How, students, you tell me, in 1 hour 7 a.m. bus started up to 8 o'clock. That means in 1 hour bus travels for how many kilometers? 40 kilometers obviously. Alright. Now at 8 a.m. car is starting here with more speed than that of the bus. This is 60. Obviously car can catch the bus on the way. Now the question is, when the car is going to catch the bus? Simply, students, with the common sense we can say, since car speed is more than that of the bus, definitely it is going to be bus is going to be caught by the car. Now here we will go a little in depth way. What is that? If the scenario is like this, in 1 hour bus comes here up to 8 o'clock. At 8 o'clock bus is here, now car is here. Suppose bus is stopped here only. It is not in the movement. Try to understand clearly. It's not in the movement. Bus is here only. It is not going further. Now this one car started at 8 a.m. or starts at 8 a.m. When the car is going to catch the bus? In this case, students, for car the distance to be covered is only 40 kilometers here, because bus is stopped. It's not going further. Now here obviously when car is going to catch the bus, that is time is equal to distance by speed. Here the distance for car is 40 kilometers and the speed of the car is 60 kilometers per hour, that is 2 by 3rd hour. 2 by 3rd hour after 8 a.m. 2 by 3rd hour after 8 a.m. or 2 by 3rd hour, you just convert that one into minutes. This should be 40. Okay. So 8:40 a.m. the car is going to catch the bus. Listen very carefully. If bus is at stationary position here, stationary position, my answer is clearly 8:40. But now the question is, we are moving towards relative speed concept. Now you see students, bus is not stopped here. Here from 7 to 8 a.m. bus had traveled for 40 kilometers and it is not stopped here, it is moving further. 8 o'clock car started with 60 kilometers per hour. Now when the car is going to catch the bus? In this case students, same thing, I need time, time is equal to distance by speed. But here the term I use for distance is lead distance, this one. What's the meaning of lead distance? For car, the bus is also moving then, car is also moving. But in this case also, whether the bus is stopped or moving, since both are moving, for this car, lead distance is 40 kilometers only. Why is this lead distance? Because both are moving towards in the same direction. That's the reason why I use the word as lead distance. For this car, 40 kilometers is the lead distance divided by speed here. Now I cannot take only speed of the car because bus is also in movement. For that reason, here speed will be reduced. Relative speed concept comes into picture. Since both are moving in the same direction, as I have explained here, 20 kilometers example, as I have explained here, relative speed is 60 minus 40. So here 60 minus 40, it is 20 kilometers per hour. Now in how much time the car is going to catch the bus when both are in the movement, that too in the same direction, that is 22 times, of course this is 2 hours. What do you mean by 2 hours here students? Here 2 hours after 8 o'clock, because after car starts only I am going to count the timing. 2 hours after 8 o'clock, that means in this case that is 10 a.m. okay. Previously when bus was at the stationary position, it was only 40 minutes. 2 by 3 hour means that is 40 minutes. 8:40 a.m. right. Now this is 10 a.m. Have you understood the concept of relative speed? Now I told you that I would explain you in 5 minutes, but it took 15 minutes for me to explain that one. I've explained with only simple example, very simple example. Okay, now come back to this question. So I hope this is clear for all of you, right? Now come back to the first question. We have left out something here. What's that one? From place A, bus and car both started here. I told you. Then after that, here at this point, after traveling for 1 hour, at this point bus increases its speed to 40 to 80 kilometers per hour. Now you solve this question. 80 kilometers per hour. Now you see students, let's take this as the starting point, as that one. This is the starting point. Now car is moving with 60 kilometers per hour, bus is moving with 80 kilometers per hour. Now the distance between these two is only 20 kilometers. Now the question is, from this point, this is 8 a.m. now. From this point to catch the car for bus with 80 kilometers per hour, how much time would it be taking? Same here, time is equal to lead distance divided by relative speed. Here the lead distance is 20 divided by the speed of the bus is 80 kilometers per hour and speed of the car is only 20 kilometers. Even in this case also, the relative speed is 80 minus 60, that is 20. 20 by 20. What do you mean by this one here? Just example I have taken here, 1 hour. Now the bus is going to catch the car in exactly 1 hour. 1 hour from 8 a.m. That means by 9 o'clock bus is going to meet car on the way. Is it clear for all of you? Two examples, not only two but three examples I have taken here to make it understandable to everybody there. Alright, so this one means the complete question. What is the question here? From place A, bus started with 40 kilometers per hour, car for 60 kilometers per hour. They traveled for 1 hour. In 1 hour bus covered 40, car covered 60, the distance is 20. Now the bus increases his speed to 80 kilometers per hour. That means from 8 o'clock plus 1 hour, by 9 o'clock the bus is going to catch the car. In this case, the car is going to catch the bus in 2 hours when both are in the movement. Bus started 1 hour before car with these speeds. Alright, then if the bus is at the stationary position, answer was 8:40 a.m. When both are moving, the answer was 10 a.m. 2 hours after starting off the car. Hope this is clear. Now, with this basic idea, you need to solve the question. Now, let's take the question. I think now you can do this question very easily, but many twists are there in this question. I'll tell you it's a tricky question, of course. Okay, right. But let's understand the question. Already I've explained you. I'll just convert the scenario into a small diagram so that you can understand it very easily. Here, simple. Girl is here. Okay, she is moving in that direction. The thief has come and snatched the purse of the girl, and he went here up to this extent. After that, he turns towards the girl, and he met the girl after some time. This is what exactly they have given. And they are asking the question, what is the speed of the thief in kilometers per hour and what is the speed of the girl in kilometers per hour? Here, first trick you see how they have given. The time. They have given 2 times. One is 2 hours, other one is 2.4 hours. First of all, you need to understand that properly. 2 hours, clearly you see, if the thief travels away from the girl for 2 hours, that means after snatching the purse, the thief from here to here, from this point to this point, he took how many hours? 2 hours. Then after that, he changed the direction and he was coming towards the girl only. Then for this girl, from here to here, thief went, right? Girl also started chasing him. That means for girl is traveling like behind the thief. The thief changed the direction and coming here. That means for this girl, for the entire thing, the moment thief snatches the purse to the moment she caught the thief, it took 2.4 hours. Try to understand the first trick. Have you understood this hidden information? From here to here, for thief it took 2 hours. Then he is coming towards this direction. Total time taken for that girl is 2.4 hours. Got the idea? Now I'm going to use the relative speed concept to solve this question very easily. How? Let us take here the speed of the girl. I'll write here. Let's take the speed of the girl as x kilometers per hour. Okay, whatever it may be you take. And speed of the thief I'm taking y kilometers per hour. Now you tell me, students, clearly whose speed is more and whose speed is less comparatively. Of course, y is greater than x. Simple. This is the first conclusion. Now students, observe carefully. Here you try to apply the relative speed concept. In the first case, you see, when the thief had snatched the girl's purse and he went for 2 hours. That means how much distance he has traveled here? Distance is equal to speed into time. Here, since both are moving in the same direction, the speed will become relative speed. Relative speed into time will give me the distance. I repeat this one. I am finding the distance here. Distance is equal to speed into time. Relative speed into time. Now here, for this action, how much time it has taken? 2 hours. That is 2 hours into, what is the speed here? Speed of the thief minus speed of the girl, because thief's speed is more there. For that reason here, this is y minus x. What is this one, students, here? Actually, distance. Okay, now the very important trick comes into the picture. How they have given, you see, for girl, how much time it has taken for going here, thief went there and came towards. In this case, students, think very carefully. Here, from here to here, the distance I have found out. When the thief changed the mind and coming towards the girl means the distance is same. In both the cases, distance is same. Isn't it, students? Now, try to find out. First, I have taken the relative speed in the same direction. Now, thief turned towards the girl. He changed the mind and he turned towards the girl. When he is turning towards the girl, girl is somewhere here. Actually, both are moving. Somewhere here. And when he turned, in both the cases, the distance is same. Very, very important technique. While going also, when he took 2 hours, he went here. And he is turning back to the girl. That means lead distance is same. Now he is coming towards. In this case, what happens, students? Same thing. Distance is equal to speed into time. Now here the speed becomes the relative speed. Since both are coming towards each other, here speed becomes x plus y. All of you understood this one? Very tricky one. Here distance, that means girl is here, both are coming in this way. Girl is here, thief is here. Repeatedly I'm telling, don't feel bored, because beginners are there for that reason. Now thief changed his mind and he changed the direction like this. In this case, the distance is this much only. Now here you tell me, students, for this girl, after the thief snatched the purse of the girl and went for 2 hours and he came back, the total time taken was 2.4 hours. That means from here to here, the time will be 0.4 hours only. 2.4 minus 2 hours. Now clearly, students, here this is the speed and the distance is 0.4 hours, not distance, I'm sorry, time is 0.4 hours. Now in both the cases distance is same. Now I am equalizing this one, as simple as this one. Okay, here very important point here, again I am telling you why and how the distance is same. Very simple one here. When the girl, the thief snatched the purse of the girl here, she went like this. All right, the time taken was 2 hours. Now at this point, the thief is coming towards this direction. Change the mind. That means from here to here, this is the distance. While coming opposite also, the distance would be the same. Now you got the idea, right? So for that reason, I have equalized this. Now simply try to find out the ratio of speeds y and x or y. Quickly go for this one. This is 0.4. This is 2. Just take out this point. Then it becomes 20 actually. After taking that point, it becomes 20. That means 4 1 times, 4 5 times. Understood? I am doing it directly. Now here 5y minus 5x is equal to x plus y, or you just like send the x there and bring y here. Now here 5y minus y, that is 4y is equal to, this will become plus 5x plus x, 6x. Now here 2 2's, 2 3's. That means my final conclusion is 2y is equal to 3x. 2y is equal to 3x, or the ratio of y and x, y by x. I am bringing this one here. Y by x is 3 by 2. 3 is to 2. How simply I have solved the question here. Here the ratio of speeds of thief y I have taken. Thief is y here, y, and girl is x. Y is greater than x. For that reason, y is 3 and x is 2. Now got the idea? Now this ratio you have to substitute here in the given three statements there. They have given 3 statements, which value or values satisfies the condition there. Now here, since they have given that in the given order means first one should be taken as a thief's speed, second one is girl's speed. Now just go for this one, x and 2 by 3x, is it true or not? X means I am taking as 3. X is 3 because first speed is that one only. In the options, not in the question. In the options, 3, and this is 2x by 3. 2x by 3. 2 into 3 by 3. Now 3 gets cancelled and this is 3 is to 2 only. Speed of the thief is 3. Speed of the girl is 2. Now you see, this is speed of the thief 3 and 2. What do you mean by this one? Yes, first one satisfies the condition. Oh, got it? Now go for the second one. Second one, 24 and 16. Yes, 24 and 16. 24 and 16 means 8 2 times, 8 3 times, 3 is to 2. Yes, it is also satisfying the condition. I need to get the thief of the speed 3 and this is 2 in relation with each other. Alright, So second one is also done. What about the third one here? 2.5g. I'm writing here. G means whatever the variable may be, they may keep k, x, y, whatever it may be. Okay, all right. Here 2.5g and g. Now you say 2.5g. If it is 2.5g and it is to this is only g, whether it is satisfying or not. This 2.5g. Okay, 2.5g and this is g. If you go for this one, g as the first value. First value means here same thing, x 2.2 by 2x by 3 in the same way here. So if this is 3 and this is 2, here this is 3. If you keep this one as 3 and that is 2 here, these two are not matching with 3:2. Isn't it not matching there? Of course, right? So if it is 1.5g, of course it is matching, but for 2.5g it is not matching. That means I cannot satisfy here the third one. I'm not able to satisfy. Now go for the options. First option is only 1 and 2. Second 2 and 3, only 3, all 3, none of this. Obviously students, first one is okay, second one is okay. My option will be only 1 and 2 satisfy the condition. This is the way, students. I hope this is clear for all of you. See, students, to explain this one, it took this much time, but when you attempt this question in the exam or in the practice sessions after learning the basics, it won't take much time. Okay, right. Thank you very much, and we'll meet you in the next session.